Hi Bobcats, this is Miss Lee, and today's video lesson is ordering rational numbers on a number line. So let's get started. Make sure you're taking good notes. Okay, problem A, how would you order these rational numbers using a number line? Okay, let's take a look. What do you notice about these numbers? Well, I see some decimals and some percents and a fraction, right? So there are three different forms of rational numbers. In order to put them on the number line, we need to first convert them to the same form. Change them all to percents, or all to fractions, or all to decimals. And honestly, I would not change them to fractions because that's a lot more work and it's easier to make a mistake. So I would stick with changing them all to percents or all to decimals. Now, I personally am going to change them to decimals. I'm actually going to put them in the money format. Money I'm super familiar with. I like to spend money, so that's what I'm going to do. It'll be easier for me to see which is bigger, which is smaller. But it's easy to look at that same way with a percent too. So it's really your choice what you prefer. So the first one is already in decimal format. It's 4/10. To let it look like money, I'm going to add a 0 so it looks like 40 cents. Then we have 80%, and we know to change our decimal to a percent, we're going to use our DP. Percent to decimal goes 2 places to the left. So here's my invisible decimal. I move it 2 places to the left, and it becomes 80 cents. I'm going to write that right above it. I'm actually going to write my 40 cents up here as well. I'll put all of my new numbers up here. Then we have 1/10 as a decimal. I add a 0, it's 10 cents. We have another percent. There's the invisible decimal point, 2 places to the left, and it becomes $1.60. My decimal 1 3/10. I'm going to add a 0 to make it look like $1.30. We have another percent. Move that invisible decimal 2 places to the left, and we get $2.50. And then we have the fraction. And when I read it, 2 9/10, it sounds like a decimal, doesn't it? 2 9/10. So I'm just going to rewrite it by adding the 0 so that it looks like $2.90. Okay, everything's been converted. 4/10, if you wanted to change it to a percent, then you would go from decimal to percent 2 places to the right, and it would become 40%. 1/10 would be 10%. 1 3/10 would be 130%. 2 9/10 would be 290%. Okay, so we're ready to put it on the number line. Now we have to look at our number line and see how it's being numbered. And I can see that it's being numbered by whole numbers, 0, 1, 2, 3. But each whole is split into parts. So when I count them up, there's actually 10 parts. So each whole is cut into tenths, or money format, 10 cents. If you're doing percent, it would be 10% each. So using that, we're ready to go ahead and put this on our number line. My first one is 40 cents. So I'm going to count here 0, 10 cents, 20, 30. So this would be 40 cents. And I need to label the rational number. But I'm not going to use my 40 cents. I'm going to use the original rational number we were given. We were given 4/10. So that's what I'm going to write. There, 0 and 4/10. Okay, now I'm going to move on to my 80 cents. Well, that's going to be 20 cents less than $1, so it'll go right here. The original format is 80%. I'm kind of writing sideways, so I apologize if the numbers look kind of bad. Okay, 1/10, well, that's easy. That's 10 cents, so right there, and the original format is 1/10. Then we have $1.60. So here's $1, 10, 20, 30, 40, 50 cents, 60 cents. And the original format is 160%. 1 3/10. So here's 1, 10 cents, 20 cents, 30 cents. So we list it as 1.3. 250% is 2.5. So there's 2, 10, 20, 30, 40, 50. The original form was that 250%. And last but not least, $2.90. That's going to be 10 cents less than the 3. And the original format is 2 9/10. 2 9 over 10. And there you go. We have now ordered these rational numbers on the number line. Okay, let's go to problem B. What about these numbers? How are they different? How are these rational numbers different than problem A? That's right, they're negatives. So what I would like for you to do is to pause the video, and I would like for you to convert each rational number either to all decimals or all percents, whichever you prefer. When you're done, come back and see if you've converted them correctly. Okay, let's see. The first one was an improper fraction, so it's easier to go ahead and change it to a mixed number first. And when we do that, I forgot my negative sign here. It's a negative 1 1/4. I know 1/4 is a quarter, so it's a negative $1.25. For the second one, we have 20 as our denominator, so I changed it to 100. Used a scale factor of times 5, and 3 times 5 was 15, so it was a negative 2 1/1500. I wrote that in decimal form. If you were going to write it as a percent, it would be a negative 215%. Then the next one, I used my DP and got negative $2.50. Negative 7/3, I converted that to improper. 3 goes into 7 2 whole times with a remainder of 1, and the denominator stays the same. So it's going to be a negative 2 1/3 as a decimal as the repeating 3's. So negative 2 33 with the repeat bar. Okay, negative 2 2/5, I converted this to the tenths place. So I got negative 2 4/10, which would be negative $2.40, or as a percent, it would be negative 240%. And then the last one, I just added a 0. Okay, so hopefully it checked out. You got the same conversions that I did. Now go ahead and pause the video and plot your points on the number line, and then come back to see if you plotted them correctly. Okay, take a look, see how you did. Just remember, when you're plotting the points on the number line, when you're labeling them with their rational number, to use the original rational number format. And they all seem to be clustered right here in this section, so it was a little hard to write them in there, but we got it. So just pause the video and check. Once you've checked, come back and let's work problem C. Okay, so here's problem C. Problem C, it's the same type of rational numbers, except for now we have a mixture of positive and negatives. So pause the video, go ahead, do your conversions, come back, check them, and then we'll move on. Okay, go ahead and check and see how you did. See if you converted them all to the correct format. Remember, 1/2 would be 50 cents. A negative 9/10 would be a negative 90% if you were using the percents. Couple of them, we had to think about it. We had this mixed number. We had to change it to an improper fraction. 27/10 turns into 2 wholes and 7 remainder out of 10, so 2 7/10. And then the last one, we actually had to simplify that fraction first. We had to divide by 3, and that gave us a negative 2 3/5, which we could then change into tenths, and we ended up with negative 2 6/10, or negative $2.60, or as a percent, negative 260%. Okay, now we're ready to plot them on our number line. Our number line is blank. It's just a number line. So we're going to have to number our number line. So when I look up here, I can see that the largest rational number is the $2.70. So that means our whole numbers, positives, need to go up to positive 3. And our smallest number is going to be the negative $2.60. So we need to go down to negative 3. So we're going to put 0 in the middle. This will be positive 1. This will be positive 2. This will be negative 1. This will be negative 2. Okay, and it doesn't have to be perfect. You don't have to have it exactly even each space. And now we're going to go ahead and plot. 50 cents. Well, it's a positive, so that's halfway between 0 and 1. So I'm going to label it 1/2. 30 cents. Well, that's going to be between 0 and 50 cents. So it's going to be about right here. It doesn't have to be exact. So this will be 30%. Negative 90 cents. Well, that's between 0 and negative 1, and it's closer to the negative 1. So I'll put it right there. Negative 9/10. 180% is $1.80. That's close to $2. So I'll put it about right here. and I'll label it with the original rational number, which is 180%. Then we have a negative $1.50, so that's halfway between -1 and -2, labeling it -1.5. 27 tenths, $2.70. Well, that's greater than 250, closer to 3, so about right there. So that's going to be 27 tenths. And then we have the -$2.60. Here's -2. -250 would be right here, so -260 would be a little bit larger. And the original rational number was -2 and 9/15. All right, Bobcats, good job. That's how we order rational numbers on a number line.